Inshallah, in this class, we are going to discuss the formulas and little concept of the locus, which we will use in the chapter locus. Okay. Before going to the formulas, let me have a little description of the definition of locus. We'll try to understand. You see here, locus in locus always we consider a point, moving point. Suppose, or we can say the set of points. Whenever a point moves, okay, or we can say the set of points which are moving. I'll explain with an example. Suppose you see here, we are having a fixed point, suppose for instance 3 comma 2. Now there is a point, moving point, which is always at a distance of 3 units from this point. Suppose there is a point which is 3 units from this. So whenever this point is moving, the distance from this point will be 3 units. Suppose here, so what is the distance here? 3 units. Again, if the point moves here, what is the distance here? 3 units, like that. So whenever the point is moving, the distance will be 3 units. So can you imagine what will happen if we join all the points? If we join such all the points which are at a distance of 3 units, so this will form a circle. This will form a circle. So we say that the equation of locus of these points is a circle. So the set of points which satisfy a given geometric condition. What is the geometric condition? The points are moving such that it is at a constant distance from the point 3 comma 2. It is at a constant distance of 3 units from the point 3 comma 2. In short, you just remember that the locus, in locus we always consider a point which is moving point. Okay. So suppose for instance, if the point is always at a equidistant from 2 points, suppose we are having 2 points. So equidistance means here, if you take here, it will be equidistance. If you take here, it will be equidistance from 2 points. So such points, if you join, it will become a straight line. It will become a straight line perpendicular to the point line joining the points. So just we can say that the set of points which satisfy a given condition, geometric condition, is called locus. Now the first formula what we are going to use, the distance between the 2 points. Suppose we are having 2 points ax1 y1 and bx2 y2. So the distance between the 2 points, the length, we can say also the length AB or the distance between the 2 points is given by under root of x2 minus x1 whole square plus y2 minus y1 whole square. But generally we don't want root, okay, for solving. So square this one. So if we square this one, this will become AB square. And here the square and root will get cancelled. What is left here? X2 minus x1 whole square plus y2 minus y1 whole square. So remember this one, generally the distance formula is with root. So therefore we square on the in the questions to take out the root. So we generally we can use AB square equals to x2 minus x1 whole square plus y2 minus y1 whole square. Now the distance of the point from origin means one point is this. Suppose origin is another point is this. So x minus x2 minus x1 means x minus 0 whole square, y minus 0 whole square. In short, we can write distance equals to under root of x square plus y square. This is the formula for distance from origin. Now you see here, let we are having a triangle. Suppose its vertices are given x1 y1 x2 y2 x3 y3. Suppose we want to find the area of triangle ABC. We are having many formulas, but I prefer this formula. Half of mod, easy to by heart, x1 minus x2, x2 minus x3, x1 minus x2, x2 minus x3, like this. X1 minus x2, x2 minus x3. In the same way, y1 minus y2, y2 minus y3, y1 minus y2, y2 minus y3. So there are many formulas. I just prefer this one. What is the formula for area of triangle? Area of triangle is given by delta equals to, delta is generally used to denote the area. Half of mod x1 minus x2, x2 minus x3, y1 minus y2, y2 minus y3. Now what is this? This is called the determinant of matrix A, B, C, D. How to solve this one? You have to multiply this 2 minus this 2. This 2 First this to AD minus BC. So if you want to expand this, how we can expand? Half of, you write mod. Now multiply this to x1 minus x2 into y2 minus y3 minus, you multiply this to y1 minus y2 into x2 minus x3. How to solve, you can see in the problems. So this is the determinant we expand. Why you are using mod? Because area must not be negative. Area must not be negative. So whenever we want some value which is always positive, we will use mod. Even if we get mod of minus 5, we write plus 5 only, because in mod we will not take the negative, only we get the magnitude of this value, absolute value, only positive value. Now suppose we are having an equilateral triangle, suppose, sorry, right angle triangle. Suppose this is A, B, C. We always know that this is hypotenuse. The side at opposite to 90 degrees is hypotenuse. This is always where we form L. This is 90 degrees. So actually this is height, this is adjacent. But generally we denote like this. Suppose this is theta, this is opposite, this is adjacent. Okay, or you can say height, altitude, and base. So for this, whenever we get a right angle triangle, we have to use Pythagoras theorem. Pythagoras theorem. What is Pythagoras theorem? Hypotenuse square equals to opposite square plus adjacent square. Hypotenuse square equals to opposite square plus adjacent square. So this few questions are given on this formula. So if you see in the figure, what is hypotenuse here? AC square equals to opposite is AB square plus BC square. So what are the formulas we are going to use in the locus? We are discussing that formulas only. Now see here, just one more concept here. Suppose this is coordinate axis, x-axis, and this is y-axis. Suppose you are having a point here, px comma y. So watch carefully. Now here x1, 2, 3, 4. Here the value of x is x. That means this distance is x. We can say like this also. This distance is x. This value will be x. And this value will be y. So we can write like this. Here this value is y. Now watch carefully. Can you say the distance of the point from the x-axis is y? Got it? The distance of the point P from x-axis is y, and the distance of the point from y-axis is x. So what we are having one question like this. Watch carefully. The distance of point x comma y from, suppose, x-axis. So distance from x-axis is, this is the distance. See, I write y, but we use mod y. Why mod? Because distance we should not take negative, so we write mod. And the same way, distance of the point from x-axis, sorry, y-axis. So y-axis distance is mod x. Y-axis distance is mod x. So these are the main formulas which are we are going to use in the locus. Okay. So inshallah we are continuing in the next class with the formulas of change of axis, translation of axis, and rotation of axis, transformation of axis.